So lesson 7.6 is going to take our factoring to trinomials. Everything that we've talked about so far has been all about just pulling the GCF. And I'll preface this by just saying that pulling the GCF is a really important step, because really, no matter how many other factoring methods I teach you for this next several days or next several lessons, pulling the GCF will always be the first step. It'll always be, everything that I'll start off saying will always say, first start by seeing if there's a GCF that you can factor out, and then proceed to, you know, this other step or this other step or this other step. So the lesson that we did previous to this one is incredibly important, because it will always be step one before we move on to any of our other factoring methods. So after we've pulled the GCF, or now that you've learned how to do that, what you're going to see today is how we break down or factor a polynomial into its factors if it is a trinomial. So notice at the very top it says factoring x squared plus bx plus c. That's essentially showing you a quadratic trinomial. That's going to be our emphasis, because that's leading us into the quadratic unit. But we're going to talk about how to factor that, even if there's not a GCF, if it's just those three things, those three terms right there, and we want to break it down into, I wonder what binomials got FOILed. So if you remember when we talked about FOIL, we would have two binomials, we FOIL them. Most of the time, the two middle terms combine together. In fact, let me give you a real quick example. Let's say that, you know, this is review from when we were multiplying. Let's say I've got this guy times that one. And then whether you used box method or FOIL, we knew that when we multiplied these guys together, they gave us four products, right? The first product, the outer, the inner, the last, or if you're filling in a box, there should be four boxes just like this. That gave you four products. But then, most of the time, you have a couple of like terms right there in the center that would combine. And so a lot of times, most of the time, then our final product was a trinomial, okay? Like x squared minus 2x minus 15, like you have here. Of course, now we're going in reverse. So we're trying to see how can we get from this trinomial back to those factors, those two binomial factors that that gave us that, right? So in this case, we're going in reverse of that step, and we're trying to figure out, how could I figure out that it was x plus 3 times x minus 5 if I wanted to rewrite it that way? And again, I'll remind you, why would we want to rewrite it that way? Because then we can use a zero product property when we're solving. That's the main thing. Okay, so you've got a couple of examples, algebraic and so forth here. But the bottom line is that there's a pretty special relationship between these two numbers and the numbers that we end up in our trinomial. That's what we're going to practice today. So you have a few examples right in front of you, but I'm going to jump right in. That's for you to read through as you're studying and preparing and so forth. But I'm going to jump right into this little practice that's going to help us with today's lesson. Okay? We're going to, and for lack of a better word, I always just call this magic numbers. You know, I don't know that that's official. I just always, you know, think about that, you know, like, okay, I always say, hey, find the magic numbers. And what we're going to practice is understanding the relationship between when you have two numbers, what is their sum, or what do they equal when you combine them, versus what is their product, okay? So let's practice that with this little table right here. Let's say, the first one's done for you. Let's say that the first number is 4 and negative 3. The first two numbers. If I combine those together, we get a positive 1. If I multiply them together, I get a negative 12. I think we all okay. Yep, that's true. If we combine 4 and negative 3, we get 1. If we multiply 4 times negative 3, we get negative 12. So there it's at. Okay? Let's try the next one. Let's find out what number we would need right in here to make this work and make that work, right? So I can ask myself, what, in fact, it might be a little easier to start with a product here. Negative 4 times what would give us a negative 20? And then whatever that number is, hopefully when we combine it, it gives us this one right here, okay? So let's start with the product. So negative 20, if I already have a negative 4 times what gives me negative 20? Hopefully you feel comfortable that that should be a 5. And then we can test and see, does negative 4 combined with a positive 5 give us a positive 1? And yes, it does, right? So check. Right? Let's practice now without having any numbers. Again, we're looking for two numbers that satisfy this sum and this product. So now we're looking for what are two numbers that add up to 5 and multiply to 6. That's what we're trying to find out. Okay, so think about it. Put pause on the video if you need to think about it. I'll give you like 2 more seconds. And hopefully you've thought about the fact that I think 2 and 3 will work, right? So 2 and 3, when we combine a 2 and a 3, they combine to give us a 5. When we multiply a 2 and a 3, we do get a 6. Okay? Try the next one. This one's a little more interesting. The product is negative. Okay? We're looking for two numbers. This is a skill you're going to be doing, so practice this. Take the time to do this because it will help get your mind into the right mindset, right, to make this work. So think about what are two numbers that multiply to give you a -6. They have to multiply to give you -6, but they combine to a +1. Okay? And this is interesting because if they combine to a negative, and if it helps, you can kind of put this off to the side. If they combine to a negative, you know the signs have to be different. And the minute you realize that, then hopefully you realize that when you combine them, they're going to subtract. So that's why this is so small. Okay? You're probably expecting these to end up subtracting to a 1 or have a difference of 1. So since the signs are different, we're going to be looking for a difference here. Okay? And so if we kind of make a list, and when you're not sure, this is what you would do. I know 6 is pretty easy, but you might do just a list of factor pairs, right? And say, okay, 1 and 6 and 2 and 3. And it's negative, so one of those has to be positive or negative. So if I made that a negative, that'd be combining to a 5. That's not going to work. If I made that one negative, it'd be a -5. So that doesn't work. But here, 2 and 3, maybe if I make that guy negative, those multiply to give me a -6, and then when I combine them together, they result in a +1. So my numbers are -2 and +3. Okay? Check out the next one. It's actually almost the same problem, except when we combine them, they have a product of -6 still, but when we combine them, it was a -1. So perhaps that means that in that case, the negative should be on the 3, being the larger number, and giving us a result of -1. So maybe on this one, it would be the same 2 digits, but the negative would be on the 3. That way, when we combine them, the difference is a -1. Okay? All right. How about number, we'll finish up with this one, and then you hopefully you get the idea here. So we've got a -9 here. We're looking for two factors of -9 that have a difference of 0. So again, if you need to, make yourself a little list here on the side. Think about what multiplies to -9. Well, 1 times 9 or 3 times 3. And my signs have to be different because if the product was negative, the signs would have to be different, right? Right away we know these are not going to have a difference of 0, but the -3 and the 3 will. So -3 and +3 multiply to give us a -9, and then when we combine them, they give us a 0. That relationship of being able to kind of flip back and forth between multiplication and combining or addition and subtraction is really at the heart of how we factor trinomials. So now let's put this in practice. Okay, so this is how we're going to do this. We're going to essentially unfoil this trinomial, following the reverse of the FOIL process. Okay, and we're going to use the trick that we just learned. So I'm looking at c squared plus 8c plus 7. And this is what we do, guys. Check it out. We take this last number, okay, the lowest degree, the constant. And I usually make a little x. You'll see me do this all the time. I'll put a little x here. And I'm going to put it on the top of the x. And I'm going to basically say, okay, I'm looking for two magic numbers like we did a minute ago, right? What are two numbers that when I multiply them together, they multiply to 7. And when I combine them together, they combine to 8. Okay? That's the question, right? So we're trying to find what two numbers would make this work, that would multiply to a +7 but combine to 8. And this one's pretty simple, mainly because 7 is prime. So my list is very short, right? I only have two options of numbers that multiply to 7, and that is 1 and 7, okay? But if we test that, we see that it does work, okay? We know that 1 times 7 does indeed give us 7, so it works up here. And that when I combine a 1 and a 7, I get an 8. 7 plus 1 is 8. Okay? So my magic numbers that I'm going to want to use in this problem are the 1 and the 7. Okay? Well, what we're going to do next is simply split, well, let me rewrite that. Rewrite this as the product of two binomials. And kind of think about the pattern of FOIL. So remember, when we do FOIL, the first product was this times this guy, the first two terms, right? Well, what are the only two things I can multiply together and get c squared? Well, it's c times c, right? So in this particular type of trinomial, when we only have a variable squared, we right away already know half the work. We already know half of the binomial there. If that first term is c squared, the only way we could have achieved that is if the first term in each of our binomials was a c and then another c. Okay, so what we really are trying to find are what are the constants on the other side here. Okay, well guess what? You just found them. That's these magic numbers right here. Okay, so if you decided that 1 and 7 were the numbers that worked, then that is what you had to fill in here. And those are your binomial factors. Let's test that. And in fact, when we test it, we'll see why this always works. So we're going to test it by foiling this and making sure it does indeed give us that trinomial. So I'm going to do FOIL. I did box earlier. I'm going to do FOIL now. So this is why this works. Because if I were multiplying this like we were a couple of weeks ago, my first product would be c times c, which is where the c squared came from. Okay? Then I would do the product of the outer factors, which would be c times 7, which would give me a 7c. After that, I would do the product of the inner terms, which would be a 1 times c, or a 1c. These are positive. Should be filling that in. And then in the last term, it would be the product of those last two numbers, 1 times 7, which is just a 7. Okay? And so what I end up with is in this last spot, I always get the product of those two numbers. And in the middle, I get two terms that have those coefficients, and they always combine for us there. Okay, so I get the 8c, I get the 7 over there, and the c squared in front, and the magic numbers did indeed work. Okay, so our factors, we're not a lot of room here, but this is our factored form, and that's how we found it using that trick with the magic numbers. So let's just see that again, one more time. Okay, let's try number 2. You have a trinomial. This, by the way, I should have said this at the very beginning. This particular method only works when that very first term is just your variable squared. In other words, and you should understand what I say when I say this, your leading coefficient is 1. This only really works when your leading coefficient is 1. Okay, if there's a number in front of that leading term, that's a whole nother ball game. Very different process. Takes a little longer. So this particular method is only going to work for us in this lesson like this, where if you notice all these trinomials, the leading coefficient is always 1. All right, but let's try it again. So since our leading coefficient is 1, right away I know that my two binomial factors are going to start with an a times an a. So I already kind of know half of the work. Okay, and so what we're really trying to discover is where were the other two, what was the rest of those two binomials? What were the constants or the numbers right after it? And we'll use this little magic number trick. So we're looking for two factors of 64 that when we combine them, combine to 16. Okay. Now, if 64 is positive, so this is where, let me just pause and just give you some wisdom right here. Okay. This lesson is going to be pretty comfortable if you're rock solid on your sign computation. Okay. I'm going to be really honest. If you're still shaky, struggling, a little weak on your computation with positive and negatives, this can be a little bit challenging because you're going to be playing a lot in your head with positive and negatives and with multiplication versus addition and subtraction. And so you got to be able to juggle those rules pretty comfortably. So to that end, this is what I'm saying. If this 64 is positive, if right away you see you have a positive product, that should immediately tell you that your two magic numbers have the same sign. They have the same sign. It's either a positive times a positive, which resulted in this positive product, or a negative times a negative, which resulted in a positive product. Either way, it results in a positive product if the signs are the same. And then you kind of have to switch gears and say, well, if they're the same sign, then I'm going to find the sum. So I'm looking for things that add up to 16. So I'm looking for two numbers that multiply to 64 but add up to 16. Okay, and if you need to, you can make a little side note and start listing factors. If it doesn't jump right at you, you might have to do that. You might have to think, okay, 1 and 64, but that doesn't add up to 16. 2 and 32, no, that still doesn't add up to 16. 4 times 16, nope, that still doesn't add up to 16. And then you could be like, oh, 8 and 8, boom, that adds up to 16, bingo. So my numbers are 8 and another 8. And so then I just fill those, I fill those in. Both of my magic numbers are 8. And then easiest way to check to make sure you did this right is FOIL it back and make sure it does indeed equal the original trinomial. Okay, if you can FOIL that and it gives you a squared plus 16a plus 64, then you know you did it right. Okay, but essentially that's what you're looking for. These two numbers should add up to the middle but multiply to the end term. And if so, then that's our answer. And since this one's the same, this is a really nice way to write that. Okay. All right, try number 3. And perhaps pause the video here, try it on your own, and see if you can successfully find what those two special numbers are and write the factors on your own. So go ahead and press pause, try it, and then, unpause the video and see if you're on the right track. Okay, so you should have worked this out by now. So this is essentially what we're trying to find. What are two factors of 18 that combine to 11? And it's a positive 18, so they should add up to 7. And if you came up with 2 and 9, then you are right on track. 2 and 9 multiply to 18, but add up to 11. So when I go to factor this trinomial, since it's one of these simpler ones, I'm going to put an x in front of both. X times x gives me x squared. And then what I needed to do was just find these other two constants, which we just agreed must be 2 and 9. And then you can test that. You can always FOIL it back. If you're in the middle of a test or a quiz and you have the time, that is well worth the time and effort to make sure you didn't goof anything up. And then you can say, yeah, that's my answer. So this is the factored version of that trinomial. All right, so I'm going to do one more here. See, which one do we want to do? I guess let's try number, I guess number 4. And then you can try the rest and check them against the answer key. So let's take a look at number 4. D squared plus 6d plus 8. So again, I know that right away, this is going to have a d for both of those first binomial terms. And then we're looking for what are two factors of 8 that combine to 6. Pretty quickly, you can think, oh, it's 4 and 2. That multiplies to 8, but adds up to 6. So that's what I fill in here. Okay, if you feel pretty comfortable with those, you can try 5 and 6 on your own and check them. But I'm going to actually move on, and we're going to start involving some negatives here, because that does change the game a little bit. Like I said, if you're comfortable with your negatives, this will be okay. If not, you might need a little extra support. Just check your work. Be really careful if you know that, positive and negatives are not your strength. Okay, but this will strengthen it. I mean, this kind of practice will really help solidify those rules for you. All right, let's try number 7. So on number 7, we've got b squared plus 3b minus 54. We'll start it off. I know if it's b squared at the beginning. Oh, no, it's just a b and a b. I'm trying to find the second part of those binomials. And I'll play the same game. I'll say, hey, what are two factors of 54 that combine to 3? Except, this time I want you to notice that the 54 is negative, which hopefully right away tells you that your magic numbers, they must have different signs. That's the only way that we can multiply two numbers and get a negative product, is if our signs are different. And then if you switch, right, into addition subtraction, you know that when you combine different signs, you're actually subtracting and finding the difference. So we're not looking for two factors of 54 that add up to 3. In fact, you could probably figure out pretty quickly that that ain't going to work. That anything that adds up to 3 isn't going to give you 54. But we are going to look for two factors that have a difference of 3. What are two factors of 54 that have a difference of 3? And after a little bit, you hopefully will come up with, 9 and 6. I know 9 and 6 multiply to 54, but when I find the difference between them, they have a difference of 3. And then the next thing you have to be super careful about is who should have the positive and the negative, because it makes a difference, right? The resulting 3 was positive. That tells me that the 9 must be the positive and that the 6 must be the negative. That way when I combine those, it gives me the correct sign. If not, my whole answer is wrong. Okay? So it must have been a positive 9 being combined with a negative 6. That is the unique combination, the only combination that would work in this particular problem. So our factored version there is b plus 9 and then b minus 6. All right, let's hop over here to number 9 and try this again. So on number 9, our factors are going to start with a u. Okay, and then I'm trying to find the rest. They multiplied to give us a positive 18, and they combined to give us a negative 3. Okay, so on this one, I think this one actually has a typo. This should have been a negative 18, I believe. Let's change that to a negative, otherwise that's not going to work. So if we look at this one, let's make that a negative 18 in the problem. So scratch that out. That's the typo. That's the kind of stuff I needed to make sure I fixed. And then it needs to combine to a negative 3. So since my product is negative, my signs are different. If my signs are different, I'm looking for a difference, right? So different signs, we find the difference. So what are two factors of 18 that have a difference of 3? Well, hopefully 6 and 3 jump out at you, at least eventually. And then if the result or that difference was a negative 3, you know the negative must have been on the larger number. Okay? So it must be a negative 6 being combined with a positive 3. That combination will give us a product of negative 18, but combine to a negative 3 in the middle. So there you go. So our rest of the binomials are u minus 6 and u plus 3. Okay. All right. Let's see. Which one do we want to try here? Let's just try number 10. And if we feel good about that, we'll move on. So on number 10, z squared minus z. Remember, this is a 1 here. If I don't see anything, if that helps, you can write it in. It's a negative 1 there in the middle. And then a negative 56 on the end. So we've got a z is the first part of our binomial. We're trying to fill in the second part. What are two factors of negative 56 that combine to a negative 1? And again, if that is negative, then we know that they have to have different signs, and therefore they have a difference of 1. Difference of 1. That means these numbers are really close to each other. Okay, so that's a hint right there. I'm probably not going to go for 1 and 56. They have a very large difference, right? So if they're a difference of 1, they're probably right up next to each other. So think about two numbers that are right up next to each other, then multiply to 56, and hopefully 7 and 8 are screaming at you at this point. It's me, right? And so we've got, and of course the 8 has to be negative if our difference was a negative 1. So our magic numbers are negative 8 and a positive 7. And those are the factors. And again, any one of these you could be foiling to check to see, just to make sure that it works. Okay. All right. So I'm going to let y'all finish those off if you want a little extra practice, and then you can check them. But let's go ahead and bring this together with actually solving polynomials using the zero product property like we have been doing. So we're going to now link this up to what we had already been practicing and doing, because that's the purpose of this primarily, is to be able to rewrite it in factored form so that we can then use a zero product property. So let's take a look at number 13. Okay, you have g squared minus 13g plus 40 equals 0. First of all, make sure it's set equal to 0. If it's not, you'll want to fix that first. Second of all, let's factor the trinomial so we can rewrite it as a product of two things. Okay, that's what we're going to do, what we did a moment ago. So now that it's equal to 0, let's factor the trinomial. And we know that if it's g squared plus 13g plus 40, we know that the first term must have been a g times a g. Okay, so we'll use this little magic number trick to fill in what those binomials must have been. So we are looking for two factors of 40 that combine to negative 13. And on this one, the product is 40, which is positive, which means my signs have to be the same. And if my signs are the same, I'm looking for the sum, right? So same signs, we find the sum, okay? So what are two numbers that are multiplied of 40 but have a sum of 13? So if we think about that, after a little while, hopefully the numbers 8 and 5 come to mind. And they both have to be negative. That's okay, because it still multiplies to a positive, right? But if they're both negative, that's the only way I can make this work. A negative 8 and a negative 5 multiply to positive 40, but they combine to a negative 13. So G minus 8, it doesn't really matter. Actually, that's one thing we haven't talked about. Does it matter which one you put it in? Nope, as long as the sign in front of it is correct. So as long as it's a negative 5 and a negative 8, it doesn't matter which one you write first or second. There's no right or wrong on that, as long as the sign is matched up to the correct digit or to the correct number. Okay. All right. So this is what we had been practicing. We have it in factored form, except now we're going to continue this process and actually solve with a zero product property like we've been learning. So now that I have this in factored form equal to 0, then I know that the only way that this G minus 8 times this G minus 5 can equal 0 is when either, oh, it's a cube, G minus 8 is equal to 0, or when G minus 5 is equal to 0. So now this should start to feel really, really familiar and comfortable. Now we just take each factor, set it equal to 0, solve these little mini equations, and get an actual solution. Before we were just practicing how to factor it, but now we're getting an actual solution. So the two solutions for this particular polynomial would be G equals 8 and G equals 5. And if you take, and I highly recommend you do, take those two, either of those, one at a time, plug them back in, you're going to see it works. You're going to see if we plug in either one of those. In fact, let's do that, because I was talking about it, now I just want to. Let's try 8. So if we do 8 squared minus a 13 times 8, and then plus 40, we should get a 0 if we did this correctly. So I'm just taking that original up there, plugging in G equals 8, making sure I didn't mess anything up. Okay. Well, let's see. 8 squared is 64. 13 times 8. Oh, well, let's see. That's 80 and 24. I believe that's a 104. I hope. And then that's a negative, and then plus 40. Okay. And if we do that, if I do 64 minus 104, that happens to be a negative 40. And then negative 40 plus 40, hey, guess what? That's 0. Ding! It works. It's awesome. Math is amazing. Okay, let's try one more. Let's try number 15. Let's skip over to that one. You got w squared minus 7w plus 10 equals 0. So it's equal to 0, check. Let's factor it. So it's a trinomial with a leading coefficient of 1, so I can use this method, w times w here. Let's find our magic numbers. What are two numbers that multiply to 10 but combine to a negative 7? So think about things that multiply to 10 but combine to 7. And I'm thinking 2 and 5, and they should both be negative because they multiply to a positive 10 but combine to a negative 7. So I know that these two numbers would make this true. Okay? So now I have the factored version of the same polynomial, and it's equal to 0. And now I can finish this out by using the zero product property and say if this times this is 0, then that's only going to happen when w minus 2 is equal to 0 or when w minus 5 is equal to 0. And then we just solve each little mini equation. So one solution is 2, and the other solution must be 5. There you go. Those are the solutions, and you can test them like we did on number 13 and make sure they work. All right, we're going to try one more. Let's finish out here with number 16, and then we'll try the word problem last. So if you look at number 16, the main thing I hope really jumps out at you here is that it's not equal to 0. And that's a deal breaker. So the first thing you want to do, like your life depends on it, is move that 30 to the left so that there's nothing on the right, and this is equal to 0. Okay, it's not called the 30 product property. It's called the 0 product property. It only works when it's equal to 0. So I'm going to leave the x squared minus the x, and now I'll have that negative 30 on the left, and nothing on the right. That's always the first thing. Set it equal to 0 if it is not already. Then we can start factoring. And again, it's a trinomial with a leading coefficient of 1, just like all the other stuff we've done today. So I'm going to start off with x times x here. And now I'm just on the search for those two special numbers. So what are two numbers that multiply to 30 that combine to a -1? So when I think about factors of 30 that have a difference of 1, 5 and 6 really come to mind. And since it's a -1, the 6 has to be the one with the negative sign. So again, it doesn't matter which one I put in which parentheses, but this negative has to be with the 6, and the positive has to be with the 5. Otherwise, you have the wrong numbers, and your whole solution will be incorrect, because it will not have been factored properly. Okay? So there it is in factored form. You could FOIL that if you wanted to make sure it works, but it will. If those two numbers combine to the middle and multiply to the last, you're in good shape. Okay, and then we can then proceed with the zero product property. If this times this equals 0, then that means that either x minus 6 would have to be 0 or x plus 5. I think y'all are getting the idea, hopefully, here. So we'll add 6 on both sides. One solution is when x is 6. The other solution is when x is equal to a -5. There it is. There's our solution. All right, let's finish out with our little word problem here. So we'll do number 19 right now, and number 20 we're going to do in class together. So make a note of that. This one will be in class together, number 20 tomorrow. Let's take a look at number 19. It says the area of a right triangle is 16 square miles. One leg of the triangle is 4 miles longer than the other leg. Find the length of each leg. So when they don't provide it, it's the first thing I'm going to tell you is always draw a picture, right? So let's draw a picture of a right triangle. Boom. When they talk about the legs, they're talking about the two shorter sides. So we know that this triangle has an area in here of 16 square miles. And we know that one leg is 4 miles longer than the other. So I don't know anything about this leg, but I know the other one is 4 miles longer, so x plus 4. It's 4 more than the other one. So I can establish it like this. And that's enough information for us to solve for x as long as I remember the formula for area of a triangle. So let's review that. So I know that when I want the area of a triangle, I can do 1/2 the product of the base and height, or the two legs here, and that'll give us area. So we can fill in what we know into the formula for area of a triangle. So we're going to do 1/2. The base here can be our x, and the other leg, the height here, can be the x plus 4 piece. And we know when we did that, it resulted in an area of 16. Now, be careful with this. This is super important. This looks tempting. It's like, yes, it's already factored. It's already separated out for me. There's a really big catch. It's not equal to 0. So although this looks like, oh, they gave us this gift, actually none of these factors, I always say in my best Star Wars voice, these are not the factors you're looking for. Okay? These are not the factors you're looking for, because these are not the factors that are equal to 0. So we're actually going to want to distribute this all out and clean it up, set it equal to 0, and then refactor back out. Okay? So, but you know what? I know that it's hurting your eyes. It's probably making them just, dry out and cry, that fraction is. So let's get rid of it. Let's multiply by 2 on both sides, and we're all going to feel so much better when we don't have to stare at that fraction. So it's going to be x now times x plus 4. And on the other side, it's going to be 16 times 2, right? So we multiply by 2 on both sides. It gets that fraction out of the way. Here we are. This is starting to look a little bit better. Okay, let's distribute this. So we got x squared plus a 4x is equal to 32. Let's set it equal to 0. So let's move that 32, subtract it, and get it over to the left, so that we have x squared plus 4x minus 32 and equal to 0. And this is the polynomial whose factors we need. These are the factors we're looking for, right? So we have it equal to 0. This is the one we need to actually find the factors for, so we can use our little trick. So we will find two factors of negative 32 that combine to 4. It's a negative, so I expect different signs, and therefore a difference of 4. So if you're thinking 4 and 8, you are right on track. It would have to be a positive 8 and a negative 4. That multiplies to negative 32, but combines to a positive 4. These are the factors we needed. It was x plus 8 and x minus 4, because those are the ones that are equal to 0. Okay, and then when we use a zero product property, we know that one of our answers here, when we subtract the 8, is that x could be a negative 8. The other option is if x minus 4 is equal to 0, which means that x could be a 4. And then we need to ask ourselves, realistically, can we have the length of a rectangle be a negative number? The answer is no, right? So in terms of length and distances, you can't have a negative length in a geometric figure. So this is actually not a viable option, and this is truly the only choice. So the length of each leg, the shorter one we just discovered, is 4 miles, not inches, miles. And that makes this longer one 4 more than that, which makes it 8 miles. So those are the two dimensions for the length of the two legs. There it is. And then we'll do 20 together in class tomorrow.